To be honest, Nintendo Switch consoles are not that prone to mechanical damages and breaks a lot. Broken USB-C ports, damaged glass and LCD screens, self-driven or torn analog sticks. This time I got something special. Believe it or not, but this Nintendo Switch Lite was bitten by a dog. To be more specific, the right part of the console was chewed by a dog. So here are the questions. Does this Nintendo Switch Lite survive dog's bite, and is it possible to fix it? Let's find out. As always, I was surfing eBay to find some great deals, and my attention was caught by this listing. It was a broken Nintendo Switch Lite, and I got it for only $48, including shipping. The title was describing this console as in a working condition, but dog got bite of it. That's how it got my interest. The description confirmed that the console was still working, but was chewed a bit on the right corner. The photos of the listing showed that not only part of the console was damaged, but both analog sticks were missing. Once I got the parcel, it was time to unbox it. Now it's time to take a look a bit closer at the Nintendo Switch that I bought. Honestly, it is in a pretty bad shape. Both left and right joysticks are missing, there are lots of scuff and scratches all over the housing, and the right corner is chewed up. Looking closer, you can actually see part of the motherboard got chewed off. And if I remember correctly, the right side isn't a separate board, it's a part of the main board itself. I can see that the buttons responsible for R and ZR triggers are fully missing, which means I will need to replace it from the donor board in order to make it work. Sadly, there is no free SD card or game included with the console. Let me try to turn it on. As expected, the console turns on. I can see that some buttons on the right side are not responding, and the left joystick is always traveling to the right. Luckily, everything else looks good. We have sound, the game reader works. It's about time to disassemble the console and see if I can fix the damage that it got. I will start by removing 2 screws on the top, another 2 screws on the bottom, and 4 more screws on the back of the console. With the plastic pin, I gently applied some force to lift the back cover, and it was then easy to remove. Right away, I can see the full damage that the motherboard got. We have a broken speaker, the motherboard is missing its corner, and the analog stick connector is broken. The motherboard is covered with metal shield, so I need to remove another 4 screws in order to get access to the internal components. Once I got access to the internals, I need to unplug the battery. In order to do that, first I need to remove the ribbon flex cable which covers the battery connector. Now I can easily unplug the battery connector itself. Since I'll be replacing the housing of Nintendo Switch, I am proceeding with removing the right Joy-Con logic board. The first step is to take out 4 screws holding the speaker in place. Next, I disconnect the daughter board flex cable and the speaker can be removed. Once it's done, I will unplug the analog stick flex cable, LCD light flex cable and the power button flex cable. Next, I will unscrew 2 screws which holds the L button and move it away. The only thing left is to remove 4 screws which keeps the daughter board in place. Finally, the daughter board can be pulled out. Even though I won't be using the old buttons, I'll still need the rubber pads and springs, so I'll go ahead and remove all of them. Now it's time to remove the motherboard. First, I will remove the heatsink which covers the GPU by unscrewing 3 screws which holds it. Next, I'll remove another 3 screws to free the fan and disconnect it. Once the fan is out, I can move on the headphone jack and game card reader. This requires 7 screws to be removed. along with disconnecting the card reader flex cable. After that, I'll take off what's left of the right trigger by removing 2 screws. Next, I'll unplug 2 ribbon flex cables, the first for the touchscreen sensor and the second for the LCD screen. I will also disconnect the Wi-Fi and Bluetooth antennas. With those out of the way, I can remove the right speaker. It is secured with 4 screws, and once I unplug it from the connector, it comes right out. Unfortunately, this speaker was damaged during Dog-Bite, so it will need to be replaced. The final step is removing the 5 screws that hold the motherboard in place, 2 on the left side, 1 near the fan and 2 near the USB-C port. While trying to unplug the joystick connector, it snapped off, since it was already broken. Now taking a closer look at the motherboard damage caused by the dog, I can see that the top trigger has been completely ripped off and one corner is bent. The left side of the board is cracked, with a missing section. The right joystick connector came off during disassembly and will need to be replaced. I also noticed that the screw hole near the analog stick connector is bent. Considering all this damage, there's a strong chance that this motherboard is beyond repair, but I'll still test my luck. Before attempting to do any fixes for the motherboard, I will remove everything that was left from the old console, starting with joysticks. Next, I will remove 4 screws which holds the battery housing and move it away. Once it is done, I can remove all the buttons and rubber pads left inside the housing. Now I have the full access to the touchscreen and LCD, so I can begin removing them from the housing. Before starting, I'll mark the positions of the touchscreen connector and LCD backlight flex cable to avoid any damage. Using a hot air gun, I'll carefully apply heat and slide a plastic card under the edges to separate the touchscreen from the adhesive. Once the glue is cut, both the touchscreen and LCD can be lifted out. This entire process is necessary because the old touchscreen is badly scratched and needs to be replaced. To remove the LCD, I'm using the same method as with the touchscreen, a bit of heat from the hot air gun and a plastic card to separate the adhesive holding it in place. Once that's done, the LCD finally comes free from the touchscreen. There is still some glue left on the corners, so I grab a cloth with a little isopropyl alcohol and gently clean it off. While doing that, I noticed that I accidentally damaged the top left corner of the LCD front panel. Luckily, it's not too bad, and the new touchscreen bezel should cover it completely. Now it's time to get back to the motherboard repair. To straighten out the bent areas, I used a hot air gun and carefully applied pressure, starting with the R button trigger section. With each pass, the warped parts slowly return to their proper shape. I repeated the same process on the bent parts of the board. The result is not perfect, but it is good enough to move forward with soldering the missing components to the motherboard. For the missing left joystick connector, I used a donor board I picked up from the AliExpress. First, I removed the L button trigger with a hot air gun, and then desoldered the joystick connector the same way. After that, I applied flux and tinned the old pads on my damaged motherboard to prepare for stronger solder joints. Then I placed the new R button and soldered all 5 joints securely to the board. Everything looked solid, and after testing the joints with my multimeter, I could confirm that this component should now be fully functional. Next, I attempt to solder the joystick connector, but no matter how many times I tried, it just wouldn't sit right. The main issue was the bend section of the motherboard, right where the connector needed to be soldered. So I decided to send the board to a friend who is more experienced with this type of repair. A few days later, I got the motherboard back and it looked so much better. The joystick connector was properly soldered and the previously bent areas were straightened and back in shape. While inspecting the board, I did notice one capacitor was missing, likely lost during repair procedure. To fix that, I pulled a replacement from the donor board and soldered it in place. After testing it with a multimeter, I could confirm it was working properly. Now I can place the motherboard into a testing shell and see if everything functions as it should. After reconnecting all the flex cables and antennas, it's time to power it on. The good news, the console still turns on. The bad news is that a few things aren't working. The A button and R trigger don't respond, and the right joystick doesn't register any movement at all. To start debugging, I tested all the points near the affected connections. The A button, the R trigger contact pads, and all 5 pins around right joystick connector. Next, I pulled up the Viewboard app along with Nintendo Switch schematics created by repair community. This allowed me to trace exactly where each contact point leads and check for any broken connections. Here's what I found. The first pin from the joystick goes to pin 19 on the button's input IC. That's the 7th pin on the left side. The second pin is just ground. The third pin connects to pin 17 on the same button's IC. That's the 5th pin on the left. The fourth pin leads to pin 18 of the same IC and is also tied to the capacitor just below it. And the last pin branches out to 3 places. The third testing pad on the left, pin 30 of another SMD controller, and the left pin of a tiny SMD component. As for the R button, pin 2 of the button trigger is connected to pin 41 on the same button's input IC. After running multimeter tests and probing the SMD controller pins with jumper wires, I discovered 3 broken connections: pin 5, pin 3 and pin 1. While checking over the previously replaced R button trigger, I also noticed another issue. The top rubber cap had partially melted and wasn't making a good clicking sound compared to a working one. To avoid future problems, I decided to swap it out with another trigger. Next, I moved on to soldering the wires for the missing connections. I started with the wire for the testing point 1 of the joystick connector, soldering one end to the left pin of a tiny SMD component. Then I added a second wire to point 18 on the button's IC, and finally prepared a third wire for pin 19. On the other side, each wire was soldered to its proper joint, pins 5, 3 and 1, restoring all the missing connections. Another round of testing and we hit a big problem. None of the buttons were working at all. I must have accidentally shorted some of the connections. After going over the board schematics again, I finally found the mistake. Instead of soldering the wire to point 17, I had connected it to point 18. That explained why nothing was responding. To fix it, I redid all the wiring, this time connecting the wires to the capacitors below, which share same connections, instead of soldering directly to the SMD. After some final testing, I can confirm that all the buttons including A and R trigger are working perfectly. The right joystick is also fully functional, with both directional movements and the click being properly registered. With that done, it's time to start reassembling the console. I am using a new shell, which honestly looks almost identical to the original. The font and print are the same, though the replacement plastic feels slightly rougher. First, I use a heat gun to remove the ventilation stickers from the old housing. Then I take out the game and SD card slots by unscrewing 2 screws. Next, I remove the power and volume buttons along with their rubber pad. Finally, I carefully peel off the serial number sticker located in the bottom left corner of the old housing. Now I can transfer all of these components into the new back housing, getting ready to put the console back together. Next, I move on to the new front housing. I start by placing the new joystick cover stickers. Then it's time to install the replacement touchscreen. I use adhesive tape to secure it to the front panel. After removing the protective film, I carefully position the touchscreen inside the housing. A small hiccup: I didn't realize there are 2 different sizes of adhesive, one for the touchscreen and one for the LCD, so I had to apply some adhesive tape to the corners of the touchscreen before positioning it. Once the adhesive is set, I peel off the final film and carefully place the old LCD screen back inside. After cleaning fingerprints from the glossy LCD surface, I reinstall the battery housing with pre-installed fan and secure it with 4 screws. Since the old buttons were worn and left speaker was broken, I replaced them with new ones. I also cleaned the old rubber pads with a bit of isopropyl alcohol before reinstalling. The old joysticks were completely damaged, so I swapped it with the new ones as well. Once the joysticks are in place, I install all the buttons and cover them with rubber pads. Next, I put back the left joystick daughter board and tighten it with 4 screws. Once it is in place, I install L and the L buttons and tighten them with 2 screws. Finally, I can connect all the flex cables along with the left speaker. Now I'm ready to place the repaired motherboard into the new housing. I install the replacement right speaker and tighten all 5 screws, securing the board. I reconnect the right joystick, the fan flex cable, Wi-Fi and Bluetooth antennas, followed by the LCD and touchscreen flex cables. Then I reinstall the card reader with audio jack, securing it with 7 screws. Finally, I put back R and the R buttons and tighten them with 2 screws. The old thermal paste on the GPU looked worn, so I replace it with a fresh layer. The thermal paste on the metal shield didn't look right either, so I replaced that to ensure proper heat dissipation. After applying enough thermal paste, I reinstalled the heatsink and tighten it with 3 screws. Finally, I reconnect the battery and daughter board flex cable, reinstall the metal shield and fasten it with 4 screws. With everything in place, I attach the back cover and secure all housing screws. And just like that, the Nintendo Switch Lite is fully reassembled. It's time for final testing. The touchscreen works perfectly. All buttons respond correctly. And the joysticks function fluidly. This little console, which survived a dog bite, is now fully operational. It looks and feels like new. Not only did I bring it back to life, but I also learned a ton along the way, from reading schematics to soldering tiny components in tight spaces. This project was a huge learning experience, and it feels amazing to see the results. If you like this video, smash that like button. If you want to see more, hit subscribe button. If you got something to say, leave a comment below, and I see you in the next one.